The Intelligent Community Information Model, or iCIM, is a community resource monitoring and management platform. iCIM can be deployed in communities of any scale to display and interact with 3D models of the building in the community. Within the EU-funded BIM for Rent project, IES have developed a scenario comparison tool as part of the IES iCIM platform. The scenario comparison tool can be used at the beginning of the renovation process, before the start of the design, to choose between promising renovation strategies. In this video, we will show you how to compare decarbonization scenarios within iCIM. This feature lets you evaluate the impact of different renovation interventions on a building. For this example, we will use the West of Scotland Science Park. We already have our model in iCIM, so to get started, we need to evaluate the current performance of our building. Let's select the building. Our first step is to add basic information to prepare a simulation. We click the Edit button, which opens a window with all the editable parameters of the building. We set the data to match our building. We set the space conditioning field to central heating with radiators. Also, let's say that the boiler is not modern, so we change it to a lower efficiency. We save this updated baseline by clicking the Save button. When we press the Simulate button to calculate the baseline performance of the building, the simulation runs in the background, so we can close this window. The next step is to define renovation scenarios. To do this, we switch from the baseline to a scenario using the menu at the bottom left. Now we will edit our building again, but this time we will add interventions to test renovation strategies. We do this from the ICL Interventions tab. In this first scenario, let's try a common intervention by replacing the old inefficient boiler with a heat pump with a COP of 3.5. We save and run the simulation to analyze the scenario with this intervention. Now we add another scenario with passive interventions. We switch to scenario 2 and edit our building once more. This time, we'll improve the heat generation by replacing the old boiler with the same heat pump. But we want to see what will happen with an envelope intervention too. We'll add 160 millimeters of insulation to the outer walls and 200 millimeters to the roof, and change the windows to double glazed low E panes. Again, we save and simulate, this time to analyze the scenario with the envelope insulation and boiler replacement. Now we can close the attributes pane and compare the scenario results. From the analysis tools, we click on Matrix Comparison. Here, we select our building and the scenarios we want to include in the comparison. By default, both of our renovation scenarios are already selected. We choose the metrics to include in the comparison. For example, let's look at cooling energy, heating energy, domestic hot water energy, operational cost, and total carbon emissions. We click Apply to see a side-by-side comparison of the baseline and the scenario simulation results. Here, we see that there are no changes in cooling and domestic hot water. This is expected, as the building has natural ventilation, and our interventions did not majorly affect hot water use. However, we can see quite a steep reduction in the heating energy demand. In scenario 1, we see this immediately, thanks to the huge improvement of replacing an old boiler with a high-efficiency heat pump. In scenario 2, we see how the insulation halves the heating energy demand, and the overall demand is more than 85% lower than before renovation. From this comparison, we can see the estimated annual operational costs for all energy uses. We can use this information to choose the investment that best matches our objectives for the building. We can also see that the total carbon emissions are reduced by under 15%. So, if we want to make a bigger decarbonization effort on this building, we need to look at other interventions. We can do this by returning to the interventions we considered earlier and trying more combinations. We can do this analysis on multiple buildings. Here, we have saved a scene from which we can see these interventions applied on the campus. From the metrics viewer, we can see that before renovation, most buildings need over 20 kilowatt hour per square meter for heating. When we change to scenario 1, we see that demand drop, and even more when we switch to scenario 2. With this scenario tool, you can quickly make informed decarbonization decisions before investing in your building and your community.